Hello students, welcome you all to the video lecture on Control Systems Engineering. So today in this video we are going to reduce the block diagram and we are going to find out the term C by R, that is output by input. And in the previous video we have seen that when we move this particular branch ahead of the block G1, right, we can reduce and proceed further and we can reduce the block diagram and we have obtained the C by R. Now in this problem I am going to move this H branch right before the block G1 and proceed the problem. Okay, so anyway the problem has multiple solution, you can do according to your knowledge and your observation. Okay, so for that only I am giving the alternate solution of the one particular problem. Okay, so here when you take this problem, one solution is either I can move this branch ahead of the block G1 or I can move this block before the block G1. Okay, that is I cannot eliminate this negative feedback loop as it is. Okay, so either I can move this branch ahead or this branch before, such that I can simplify your block and I can proceed further and I can determine the term C by R. Okay, so this branch H branch I am going to move before the block G1 as this. Okay, so that is the step what I am going to do. So when this particular branch is moving before the block, okay, so that is the first step, moving the branch before the block G1. Okay, so when you move this branch before, the other terms will not get affected. Okay, so only this branch will get affected. So you can redraw the diagram such that this part and all there is no change. So you can use the term as it is G1, G2. Okay, and then you have this summing point plus and plus, and then you have C. Okay, and from here you have G3. So which is going to meet your summing point. Okay, so this particular branch there is no change, and then again this forward path also there is no change. So plus and minus you have R. Okay, only this branch you are moving before. So when you are moving one particular branch before the particular block, okay, so whatever the block you are having the gain, right, that gain you have to add in a particular branch. Okay, so what you have to do means here you have H already, in additional that particular branch will be included with another term. Okay, so what is that term? So this branch is moving before the block G1, so that G1 you have to include in that particular line. Okay, so you have to redraw this diagram as this. So when you are moving the branch before a block G1, then this G1 gain you have to multiply with your H like this. Okay, so other terms and all will remain same. So when you see the block diagram, so this particular thing you can consider it as feedback path, right, that you can eliminate, and also these two terms are in series, okay, that you can combine. Okay, so that is your next step. We are going to eliminate negative feedback loop. So why it is negative feedback loop? Since you have minus in the negative feedback, right, so this is your forward path. Okay, so whenever you don't have any term or gain in the forward path, this is just a line, you can consider it as 1. Okay, here the gain is nothing but 1, and you have feedback path gain which is nothing but H and G1. Okay, so we have to eliminate this negative feedback loop. So before eliminating the negative feedback loop, again one more step I have to do, that is I have to combine these two blocks. Okay, so these two blocks are in series, similarly these two blocks are in series. Okay, so in simple what I can do means combine the series blocks or cascade blocks. Okay, so I can redraw the diagram from that as, so plus and minus remains same, here it is 1 h into g1. So when you are combining the series blocks, meaning that you have to multiply these two terms. So h into g1 will become g1h or hg1. Okay, so you have like this. Okay, similarly these two blocks are in series, so you have to multiply these two terms, g1 into g2. So you can combine the blocks in series such that you can multiply both the blocks gain. Okay, so once you have done that, okay, you have like this. So now this is your R. So now it is easy for you to eliminate the negative feedback loop as well as eliminate this parallel path. Okay, so that is what you are going to do in the next step. So this is the previous block what I have obtained. Okay, so now your third step is, let me eliminate negative feedback loop. So how will you eliminate your negative feedback? So this block is your negative feedback loop. Okay, negative feedback. Okay, how will you eliminate? Just whatever the forward path gain you write as it is. Okay, what is your forward path gain? 1, that you have to write in the numerator, then divided by, always in the denominator first term is 1. Okay, and then since you have minus you have to put plus, and this forward path gain and feedback path gain both you have to multiply. So forward path gain it is 1 and feedback path gain it is g1h. Okay, both you have to multiply and write as the second term. Okay, so forward path gain you have to write in the numerator divided by, always first term in the denominator is 1. If it is minus here use plus, if it is plus here use minus here, and multiply these two terms. So 1 into g1h. Okay, so once you have done that, meaning that you have eliminated this negative feedback loop and your input remains R as it is. Now your other terms remains same, that is g1 g2, and then you have the summing point. Okay, followed by g3, and then you have like this. Okay, so now your third step is, you can combine the parallel blocks. So why the blocks are called parallel? To this summing point both the values are coming in the forward direction, so both are getting added at this summing point. Okay, so if you have a summer like this, and if two terms are coming in the forward direction, right, and both are getting added, meaning that it is a parallel block. Okay, so this is your parallel block. So for parallel block I can add the elements in the parallel path. Okay, series means you can multiply the elements in the particular path. Parallel means you can multiply the blocks in the you can add the values in the parallel path. Okay, so first term remains same, 1 by 1 plus g1h. Okay, and then followed by these two terms, just add and write g1 g2 plus g3, that is nothing but you are combining the parallel path, and then you have C, here it is input R. Finally, okay, these two terms are in cascade, that is in series. So series means multiply, parallel means add. Okay, series block is there, so combine the elements in series. Okay, that is your fifth step. Combine your blocks in series. That is your next step. So combining the elements in series means just multiply both the terms. Okay, that is nothing but C by R. So what is C by R? Multiply these two terms and write 1 by 1 plus G1H into G1 G2 plus G3. Okay, that is nothing but G1 G2 plus G3 divided by 1 plus G1H. So this is your final C by R. So when you check the previous problem, right, previous video, there also we have obtained the same answer. Okay, so when you are moving the branch ahead or before, okay, that is not matter. You have to follow the rules of the block diagram reduction. Okay, and final solution it will be same. So you have multiple solution for the block diagram reduction. According to your view, according to your observation, you can eliminate the terms and you can further proceed and you can determine the final term. Okay, thank you. Thanks for watching.